Alrighty, with chapter 13, we're going to be focused on energy, and this is going to be, at least in my opinion, it's one of the more interesting chapters. Whoops. And with this, there's going to be a whole bunch of different information that we're going to be talking about. We're going to be looking at different types of energy, but I would also recommend you look through some of those additional resources in the chapter module, because that'll give you even more specific information on some of these if you're interested in them. But in addition to this video, just make sure you do watch the video on the cryptocurrency and how that affects the environment. We're going to see the energy that requires is going to be pretty substantial. Can even rival the energy production of entire nations in some cases. So make sure you review that video. Make sure you read the chapter, of course, and then let me know if you do have any questions. But when we're thinking about energy, the production of that energy is going to come from a whole bunch of different places. Unfortunately, we can see, and depending on where you get this data, you may see slightly different numbers, but you're going to see it this general picture where we're going to see fossil fuels making up the majority of this energy production. So we can see oil, coal, and gas. That's going to be a combined 81%. And then we just have a very small portion with those greener energy. So this is going to be the stuff that hopefully we can move towards, because that's going to be the energy that's not going to produce the greenhouse gases that are going to contribute to global warming, at least not directly. So some cases, the process of building like a nuclear power plant is going to burn fossil fuels in that respect. But then once we use the nuclear power plant, we no longer have to rely on the fossil fuels burning that carbon, producing that carbon dioxide. But as we go through this chapter, we'll look at all these different types of energy production. And then just to get another idea of the different forms of energy and kind of how they're used, this is just focused on America, but we can see over time, just the energy production overall has increased. So starting in the Industrial Revolution, we really started to see the amount of energy we were using increase. And then about halfway through the previous century, we see it skyrocket even more, just because the lifestyle choices, the number of people, just a whole bunch of different factors are requiring more and more energy. And again, we can see the majority of that coming from the fossil fuels, so petroleum, natural gas, and coal, the top three. But it is encouraging to see these greener alternatives start to increase a little bit. You can see nuclear by far the most, but with the other alternatives, we're going to be thinking about like solar and wind power. So we're starting to see those increase. And this only goes to 2012. We would likely probably see those even increase a little bit more if we had the past 10 years included on this graph. But one of the reasons fossil fuels are going to be so heavily used is because, one, they're very easy to kind of just burn, whereas the other alternatives, we kind of have to develop and improve that method so that we can actually use it as a viable energy source. But also the United States government provides a whole bunch of money to these industries, and that's why we see the fossil fuel industries being so powerful. They have a ton of money, and part of that is coming from this federally subsidized energy program. And then with the energy usage, so we saw on the previous one, the United States usage increased over time. But we're also going to see differences between different countries. We're also going to see differences within the different states. And this graph itself is a little bit misleading because it's just electricity. So it's not all energy. But you can see just in the differences here, we've got some states that are using much more electricity than the average, and then other states that are using much less. So part of that is going to be due to the lifestyle. Part of it's going to be due to how they heat and cool their homes. So the top states, I would guess, probably heat and cool their homes with electricity, where the bottom ones may not be doing that. So that's why we can kind of see some of the differences. But in general, we're going to see differences in energy needs and energy usage, just based on lifestyle, available resources, and a whole bunch of different factors. And that's what we're just seeing here. So in this graph, looks pretty confusing because we've got a whole bunch of stuff going on. On the y-axis, so going vertically, we've got the energy use in tons of oil. So this isn't necessarily how much oil is being used in these countries, but if all of the energy was being, if all of the energy used in those countries was provided by oil, this is what we would kind of see. And we can see in general, we've got a trend, a positive trend going from kind of the origin 0-0. We can see a lot of the countries would kind of fall close to a line where if we connected the origin and the United States, because in general, we're going to see as the GDP, so as the wealth of these nations increases, we're going to see the amount of energy that they're using increase as well. And then with the fossil fuels, those are the ones that get used the most often. In case you're wondering where those come from, a couple different, slightly different processes depending on exactly what fossil fuel we're looking at. But if we're thinking about something like coal, we're eventually just going to see organic matter. So different animals, whatever plants, whatever it's going to be, is going to die, and it's just going to get covered with other plants, other animals, water and dirt, and eventually we're just going to have the pressure from that material build and build, and then the pressure, the heat that's going to come with that as well is eventually going to sort of compress those organic materials into coal, and we'll see something similar with petroleum and natural gas as well. Slightly different process, but it's mostly just going to be coming from the heat and the pressure. And it's going to take a long time, so it's not going to be something that just occurs pretty quickly. So you can see the time scales here. It is something that takes a very, very long amount of time. And with those fossil fuels, like I said, we've talked about it quite a bit. They negatively impact the environment because their combustion produces carbon dioxide, going to affect global warming, contribute to global warming. There's also going to be impurities coming from metals in those compounds, sulfur, and a whole bunch of other things. There's going to be issues with just extracting those materials from the earth. So we've talked about fracking a little bit, how that can damage the earth. Damage the water quality, the air quality. Same thing with mining in general. We're just going to be releasing contamination into the environment, whether that's the surface or the groundwaters, the air, the soil. So in addition to actually the negative effects of using these fossil fuels, obtaining them is also going to be an environmentally negative activity. One positive, though, is the global use of coal is generally declining. Two of the largest users of coal are going to be China and India. They've got the developing economies, developing industries, and they've also got just a whole bunch of people in those countries. So they're burning quite a bit of coal, but in general, we're seeing it decline. So hopefully we can see that process continue. Hopefully we'll see that process even speed up a little bit so that we can move from the fossil fuels into the greener alternatives that we're going to talk about. But one thing to mention is that nuclear energy, we're going to talk about, gets kind of a bad rap for the potential to expose you to radioactive material. But you're actually more likely to be exposed to radioactivity from these fossil fuels than you are from a nuclear power plant. And then with these fossil fuels, just to highlight one sort of particular case, the fossil fuels themselves can vary in their cleanliness. So we talked about coal in particular, clean coal, which has low sulfur versus high sulfur. The more sulfur in that coal, just the more sulfur oxides that are going to be produced, the more acid precipitation we're going to see. But with the fossil fuels, we can also see that same sort of idea when we think about the tar sands that are going to be in Canada. So you can see the picture here. I think that's Alberta, I forget. Not great with Canadian geography. But in that location, we've got tar sands, which are just going to be extremely, extremely dirty sources of fuel. And what they wanted to do with the Keystone pipeline is essentially just take that tar sand, pump it down, ship it across the plains of America, that little bit in Canada as well. And with that, there's a bunch of problems because one, if there's a leak, we're going to be exposing the environment to this extremely, extremely dirty fuel. But also the pipeline itself was going to be, or the proposed pipeline was going to be built through a lot of indigenous lands. So the indigenous groups, the environmental groups, just other interested citizens just got involved, and ultimately they were able to, through public pressure, able to kind of shut this project down. And then with the natural gas, again, it's going to be a fossil fuel. It is a slightly better alternative to coal because it's not going to result in as much carbon dioxide being produced. But still, it's going to be a fossil fuel. It's going to contribute to global warming. So it's going to be something that we're ultimately trying to steer away from. But one reason that it does get used so often is because there is an economic incentive for countries that possess natural gas reserves to obtain that natural gas and then to use it as their energy source or to sell it to somebody else so that they can make that profit. And you can see the countries here that have the largest reserves of that natural gas. So America coming in at the sort of the fourth place, but Russia has a whole bunch of natural gas in it, along with Iran. So you can see in Eastern Asia, and then a lot of these, or not a lot of them, but a few of them are also going to be in the Middle East. That's where we're going to see a lot of the natural gas. But then you do get some in Nigeria, some in Venezuela. So it is located in different parts of the world. And then with that natural gas, we're looking at something like fracking a lot of the times. We're not going to go into this again since we've already kind of talked about it, but there are the issues with this because in order to obtain this natural gas, we've got to drill into the earth. We've got to fracture the earth a little bit. That's how we actually get the natural gas to seep out. But we're also injecting water with a whole bunch of chemicals in it. And then if anything goes wrong here, we're going to see some of that natural gas just escape into the environment, contribute to global warming that way. And then we'll also see this water and this chemical. We may also see the methane itself, anything else that's in this sort of system. We can see it potentially leak into the groundwater like we talked about. So in addition to just the consequences of burning these fossil fuels, or burning this natural gas in this case, we're also going to see, like I talked about, the potential for environmental destruction just in obtaining those resources. So it's kind of twofold. We hurt the environment by mining or fracking, getting those resources. We hurt the environment by then actually burning those resources as well. So now we're going to start to look at the different types of energy, and we're going to start with nuclear energy. So with nuclear energy, it's going to be kind of a little different case. So if you've taken chemistry, any type of chemical reaction you're looking at, the material you're starting with, those atoms, are going to be the exact same atoms that you're finishing that reaction with. You would just be essentially taking those atoms and rearranging them, breaking bonds and forming new bonds just so that we have new substances in the end. But the atoms themselves making up those substances would be exactly the same. But now with nuclear energy or nuclear reactions in general, what we're going to be doing is actually taking those atoms and forming something new. So in this case, and this is looking at the chain reaction that's used with uranium in nuclear reactors, but we've got a radioactive uranium atom here, so uranium-235. We're just going to take a neutron and kind of just combine those. So instead of uranium-235, now we've got uranium-236. So we haven't changed the element, it's still uranium because we haven't changed the number of protons, but we've changed it into a different isotope because we've added one mass unit to it. And that's going to make this atom unstable. So what's actually going to occur, as you can see here, is the atom itself is going to split into two. We're going to get two smaller atoms now. So we're going to get an atom of krypton, we're going to get an atom of barium, and then we're also going to release 3 neutrons. This is going to be, these neutrons are going to be somewhat important because this is going to be a chain reaction. So we'll see, we can kind of start it with one uranium, and then we'll be able to have these neutrons kind of repeat that process. We can slow it down. We'll see in one of the next slides, we'll see how we can kind of control how much of a reaction takes place. But with this process, when we're splitting this atom essentially to give us krypton and barium instead of uranium, what's going to be occurring is we're also going to be taking a very small amount of mass and converting it into energy. But that process itself is going to be extremely energetic, so it's going to release an extremely large amount of energy. So that's why nuclear weapons are so destructive, just because there's so much energy associated with them. And we're seeing something similar with these nuclear reactions in these power plants. So that's the actual reaction that's providing energy. But then with the nuclear power plant, if we want to kind of see what's going on, that would be occurring in this containment structure. So ideally, we have this built so that if anything does go wrong, all of those materials are sort of localized in that one spot rather than being released into the environment, depending on the building of that structure. And if you think about the issue in Japan in, I think it was 2011, there may be external factors that can kind of make a situation worse, but we do have these containment structures to hopefully, as it would suggest, contain those materials. But the reaction we just described would occur in this reactor vessel. And then in that reactor vessel, we've got control rods that are made of usually boron, and I think there's a second element that sometimes gets used as well. But those help to prevent a reaction from occurring, or help prevent the chain reaction from occurring, just so that we don't produce so much energy, produce so much heat, and then actually have a meltdown. But with this, we're going to have, like I said, producing a whole bunch of energy. That energy is just going to be released in the form of heat. We're going to use that to turn water into steam. And then that's going to turn a turbine connected to a generator, just producing electricity in that sense. But with these nuclear power plants, if you look, we've also got this piece called a condenser, just because we're going to have this process sort of recurring. So we're going to have the water turned into steam, turn that turbine, and then we'll recondense it. So we've always got cold water kind of running through this piece, just so that this water vapor can recondense into water and then kind of have that process occur again and again. With nuclear power or nuclear energy in general, there are the benefits, and then we're going to see with all of these, there are some level of negatives or drawbacks. But with the greener alternatives we're going to be looking at in general, the pros are going to greatly outweigh the cons. So just to run through some of these, nuclear energy, like I said, can produce a whole ton of energy. So it's going to produce for the amount of material used, going to produce an extremely large amount of energy. And it's going to be doing it without the need for fossil fuel. So it's going to be able to do it without producing those greenhouse gases, or at least without producing anywhere near the amount of greenhouse gases that a fossil fuel would produce by providing the same amount of energy. And then with this, the cost of nuclear energy is relatively low in terms of once we have the power plant built and once it's up and running. But with nuclear energy, the drawbacks to it are just going to be that generally the initial construction of those power plants is going to be extremely costly. That can be offset to some degree by providing jobs in that area in terms of building the power plant, as well as running and maintaining it once it's up and operational. But with that, we've also got costs associated with it. With every energy, there's going to be maintenance costs. Nuclear energy may be a little bit more pricey in that sense, because there is the radioactivity that kind of has to be monitored and dealt with carefully. But the most, depending on who you're talking about, obviously the argument could differ, but generally the most cited example for why nuclear energy is bad is just going to be examples like the Tokyo, or not Tokyo, Japan. I forget the actual city off the top of my head right now, but the tsunami that affected that nuclear power plant, the example with Chernobyl. So people tend to focus on the disasters, and rightfully so, because those do have the ability to be extremely impactful to the environment, to human health, and it's going to be a negative if something does go wrong. But in general, nuclear energy is going to be extremely safe. The issues with it would be more along the lines of some of these bottom ones. Nuclear energy allows for the production of nuclear weapons. So if you've got a nuclear energy system, you're typically also going to have the ability to produce nuclear weapons, which can be an issue, of course. And then also the power plants themselves could be targets for some sort of terrorist attack, just because they do have the ability to kind of wreak havoc if something does go terribly, terribly wrong. But outside of something like that, typically, at least in the current state, we don't see too much of that negative sort of result occurring from these nuclear power plants. But again, the biggest issue with them is just going to be the cost. Initially building them, very expensive, pretty expensive to maintain them, even though the energy being produced is relatively cheap at that point. But then also with the power plants, when they're getting closed down, that's often one of the most expensive parts of nuclear energy. So with these power plants, when they sort of just go through their life cycle, they become obsolete. They've been in operation for decades. Just closing them down, demolishing them is going to be an extremely expensive process as well. But I am a huge fan of nuclear energy. One of the other issues that gets mentioned a lot is what do we do with the waste? A lot of the times it just kind of gets, as this picture shows, just kind of gets barreled up and we're just storing that in one location. This looks like just some sort of underground containment area where they're just sort of stockpiling all of this radioactive waste. And in a situation like this, as long as everything does stay contained, there's really not too much issues with it. Obviously, if there's some sort of leak, that could be problematic because now we've got a whole bunch of radioactive material located in this one area. But with the radioactive waste, there are also new methods for dealing with it being developed. And one of them is actually they can take the radioactive waste and then through a pretty complicated process, they can actually sort of take that radioactive waste and have it locked in glass. So it's sort of, it's not mobile, it can't escape into the environment in any way. So it's just sort of locked in place with that glass. So that's going to be one alternative to the disposal of the radioactive material. But again, most of the time, the radioactivity being produced by these power plants or given off by these power plants would be less than you'd expect from, or less than you'd get from fossil fuels in general. Depending on where you live, you may also be exposed to more radioactivity just from bananas than you would from a power plant. So when I lived in New York, when I was actually doing my undergrad, I was student teaching at a middle school, and then there was a nuclear power plant near there. But because the power plants do have such rigid standards in terms of their operation, those students and myself were more often exposed to just low levels of radioactivity from things like bananas than we were from the power plant itself. But with these power plants, just to go back here, one thing to mention is they do require a ton of water as well, because they have to use the water to run through those power plants to keep them cool. And then also disposing of that water can then be a little bit of a challenge as well, because in some cases it may be radioactive. In other cases, it may just be warm or cold. And then if we're dumping that into the lake or river, wherever that is, there's something called thermal pollution that could kind of affect that environment a little bit. If we're dumping warm water out into a colder lake, we may attract more of the organisms in that lake to that spot just because it's going to be a warmer area. And that may have negative consequences for the lake in general, or whatever that body of water is. And then the second one, hydroelectric, so just hydropower. Now we're using essentially using gravity and just using the movement of water in a similar way. So again, we've got a turbine that's going to be connected to a generator that's going to be providing us with our electricity. But with the power plants, the way that came about was heating water into steam and then using that. With the case of hydroelectric power, in the case of dams, we're just going to be kind of as it's showing here, using the flow of water based on gravity just to power this turbine. And then based on the difference between these two sides, the difference in the level of water, just the larger that difference is, the more water, the faster that water is going to be moving. So the more electricity that we're actually going to be generating. And again, with these, there are benefits and disadvantages to all of these different types of energy. And as we go through it, we'll see that one single form of energy isn't going to be enough to provide all of the energy we need. So we're going to need to have some sort of collection of these different sources. Hydropower, we talked about it a little bit with dams during the water quality or water resources and pollution chapter 11, I think it was. And again, this is going to be something that you're going to look at with one of the written assignments when you're focusing on the Snake River dams. But just in general, so we can get a kind of background and basics on the hydropower. Again, it's going to be a green energy because we're not going to be producing the fossil fuels, or we're not going to be combusting the fossil fuels, so we're not going to be producing carbon dioxide and those other greenhouse gases. It's relatively cheap and it will provide jobs for that area. And then in addition to providing energy, the dams themselves can also sometimes provide water for drinking. In some cases, it may just create a body of water that can be used for recreation. But with the hydropower, personally, I think this is not as great of an alternative as nuclear energy, because a lot of the times with the dams, what we'll see is that they force animals out of their habitat as well. So depending on where it actually is, sometimes they may be sort of moving a whole community and forcing them to find somewhere else to live, or they may be kind of destroying an ecosystem and forcing the animals, the organisms in that area to move. In some cases, it may be a combination of both. So we often see displacement with hydropower. And again, often we talked about it, but often that impacts minority groups, lower income groups, so groups that are just less able to kind of speak for themselves or have the resources to really defend themselves and stand up. And then with this, the building of these dams, like the nuclear power plants, is going to be very expensive. And with the greenhouse, or not the greenhouse, with the dams themselves, they can actually, in some cases, wind up being worse for the environment than other alternatives. And here you can see a wind turbine. So again, we've got the turbine moving to generate that electricity. In this case, we're just having, instead of steam or water like we saw for the previous one, this one's just occurring from the movement of winds. And with wind energy, this and solar energy have been two of the biggest focuses recently. And with wind energy, with those turbines, you may have seen them. I remember when I lived in Utah, they were located in different locations, but they weren't a ton of them there. But when I drove across the country, you'd see them quite a bit more in the Midwest. But with these, again, the big thing with all of these greener alternatives is that they're just not going to be producing those greenhouse gases, or at least if there is some sort of greenhouse gas production associated with these alternatives, it's just going to be at a much lower level. It's going to be at something that we can actually kind of handle, something that we can actually work with. Whereas the fossil fuels, like we talked about, produce a whole bunch of greenhouse gases, and then that's associated with the obtaining of those sources. as well as in the actual burning of those substances. And then with these green alternatives, you've probably seen or noticed that in all of them, job creation tends to be one of the pros. That's often kind of debated because if we move from fossil fuels, we're going to be losing the jobs in fossil fuels. So that's one reason a lot of people the people in the fossil fuel industry want to keep it there, is obviously they have an invested stake in it. So they try to position their argument from the stance that fossil fuels provide jobs, but these greener alternatives are going to provide jobs as well, while also removing or at least decreasing substantially the amount of that greenhouse gas being produced. With this wind energy, though, there are some drawbacks again. For all of these, I would consider the cons to be a much lower scale than the pros. Hydropower, I would think, in some cases, be the only exception. But even if that one's done correctly, it's going to be done well. But with wind energy, with those turbines, some people have complained about the noise level. So if you have to live near them and they're spinning constantly and they're making a lot of noise, that could obviously be a negative, decrease the quality of your life. But I know at least now, I think a typical wind turbine is around 50 decibels, which is similar to just low traffic. So if it's just kind of similar to living on a somewhat busy street. But what also gets focused on a lot is that the turbines could potentially kill birds and other animals that are just flying through the air. So if you think about the turbine spinning, those birds are just going to kind of go through and get chopped up if they hit it. And then also that's going to affect the maintenance of these turbines. So they are somewhat sensitive, and something like that could affect them and could cause that turbine to be out of commission for a little bit while it needs to get whatever maintenance it needs. But again, these are going to be relatively minor disadvantages when we're thinking about the potential for wind energy to provide a whole bunch of energy to a whole bunch of people without the need to produce those greenhouse gases. And then with these, there's also, in some cases, tax incentives for these different alternative energies to sort of promote people to use them. That's going to be, especially with the solar energy, that's the one that's sort of easiest to adapt to just your house. So we see a lot of the times there is some sort of incentive for people to kind of adopt these green energies, and windmills is going to be one of the examples there. So look to see if there's anything I forgot to talk about on this one. Yep. All right. So again, the big thing is just with the disadvantages for a lot of these is it's mostly just focused on the cost. So there's usually some sort of upfront cost. There's usually some sort of maintenance cost, and that's what a lot of people try to focus on if they want to kind of stay in the fossil fuel sort of range in terms of what we're using to provide our energy. But with all of these, if you just kind of look at the cons, they're always going to be, at least in my opinion, outweighed by the benefits. And then the next one we're going to look at is solar energy. So these solar panels, you may see these, you may even have them on your home or know somebody that does. The way these work essentially is we've just got these solar panels, and then they're going to be made of different materials, but typically silicon is going to be involved. But the sunlight, those photons that actually contain energy, just hit the solar panels. They essentially knock free some electrons, and then those electrons just sort of move along the wire that's going to be giving us our electricity. It's more complicated than that, but that's the very basic setup with these solar panels. And with them, like I said, there are tax incentives to kind of increase their use. You may be able to get sort of a tax break if you put them on your home or your business, just because now you're not going to be as reliant on the energy grid, the electricity being produced. You're going to be able to produce some of it yourself. And then when we're doing this, we're not going to have any of the greenhouse gases again. Going to help keep the atmosphere clean. And then with solar energy, again, this one has been increasing quite a bit in its usage lately. One advantage, if you just compare it to the wind energy, is that this is going to be a completely silent process. So we're not going to have anything that really needs to move at all. So we're not going to have anything that's going to be really making noise. And then with these solar panels, they're effective because we can set them up pretty much anywhere that there's sunlight. We can set them up on roofs. We can set them up on the ground. We can set them up in large fields to have a large solar energy farm. But with these solar energy panels, there are some drawbacks. So obviously, we're not going to be producing any energy at night. We're going to have different degrees of sunlight throughout the year. So different, like the summer, we're going to have more sunlight than the winter. And then with these storing that energy from where it's being produced the most, we may not need all of that energy. So we're going to want to be able to store it so that we can use it when we need it. That can be an expensive and complicated process. And then with these solar energy farms, where we just have sort of a large field where we just have a whole bunch of solar panels set up producing that energy, similar to the wind turbines, that's going to use a lot of land. With the wind turbines, you could, at least in some sense, maybe plant things around them, at least have some other stuff going on in addition to the wind turbines. With these solar panels, though, they're pretty much going to take over that landscape. So it's going to be using a lot of that land, and then we can no longer use that for farming. We can no longer use that to produce food and things like that. And then with these solar panels as well, the production of them is somewhat controversial in the sense that it is going to produce hazardous waste. And then also the solar panels themselves are going to be somewhat fragile, and they're going to be, that's improved over time. So they've become more durable. They've been able to last longer. But when these solar panels eventually can no longer be used, either from just their lifetime just sort of being reached, or if some sort of event damages them, the disposal of these solar panels is going to be something that's environmentally impactful and something that we really have to think about. But one thing to also focus on with the solar panels, again, like I said, there's going to be varying levels of sunlight throughout the year, throughout the day. But also, if we're using these solar panels in an area that's already polluted, so if we've got a bunch of air pollution, that's going to affect the amount of light coming through. So that's going to be another thing that needs to be kind of considered. So there may be cities where solar energy just isn't a great option, just because the air pollution is going to prevent a lot of that sunlight from reaching the solar panels. But like I said, with these different green alternatives, we're never just going to have just solar energy or just wind energy or something like that. We're going to need a collection of all those different types to meet the different needs. Because with these energies, they're not all going to be suitable in one location. So like the wind energy, we're not going to want to set that up in a location that's not windy. It's just not going to provide a lot of energy. Solar energy, obviously not going to be a suitable option in a location that doesn't get a lot of sun. So we're going to need a combination of all of these different sources. So that's why we've talked about the disadvantages, because it's a good idea to kind of have the full picture of these different energy production sources. But again, with the disadvantages, I think they're outweighed by the advantages. But also when we think about the collective use of all of these different green alternatives, that kind of reduces some of the disadvantages, because in a location that may not be suitable for solar energy, maybe we can use wind energy there or vice versa, and then kind of just have the different energy sources being combined to ultimately reach our energy needs. And then some other ones that we've talked about a little bit in the previous chapters of biomass. This is just going to be stuff that's like ethanol, methane from biomass. With these aren't going to be perfect alternatives, because there's still going to be greenhouse gas emissions associated with them. Again, they're better than the fossil fuels. But with things like ethanol as a fuel source, the energy efficiency of it is questionable because the amount of energy that's able to be produced from ethanol is only slightly more than the energy that's needed to produce that ethanol. So it's just not an efficient process in that sense. But also with the production of ethanol, if we're using it for this sort of biofuel, now we're using that land for the ethanol for this sort of production. We're no longer using it to produce food or other resources. So that's just the environmental impact of it. With this production, we're losing out on something else, and the energy efficiency of it isn't great to begin with. And then one that you may not be as familiar with is going to be geothermal energy. So essentially using the energy of the planet to heat or cool your home. And we can see it works in the summer and the heating, because in the summer, the ground is actually going to be cooler than your home. So what we're able to do is run the system this way, so that we're essentially pumping the heat into the earth. We're taking, allowing the coolness of the earth to then cool the home. And then in the winter, what we're going to see is that the earth is going to be warmer relative. So we'll be able to use that heat to kind of heat the house in that sense. And with this is going to be particularly effective in areas like Iceland and Costa Rica, areas that may have volcanoes, areas that are going to have high temperature in those, or high temperature geothermal resources like the volcanoes and stuff like that. So we do have the ability to actually have this heat transfer. And then in addition to just the production of heat, we also have to think about how we can move, or not heat, energy. We have to think about how we can get that energy from where it's being produced. So from the power plant, the wind turbine, whatever it may be, to the source of that energy. And in America, we've kind of got it split into a couple different pieces. So we've got the western and the eastern power grids. And then Texas, you may have heard about in the news recently, as well as in the past, what was it, like year or two, whenever Ted Cruz went to Cancun because it was too cold in Texas. And then recently they've kind of had the opposite problem where the warmer temperatures are preventing the electricity from working properly. So Texas kind of has its own thing going on just because they don't have people running there. They don't listen to scientists. But then with the rest of the country as well, there are issues with the power grid getting it to where it needs to be. There is one video in the additional resources that actually talks about the cable lines themselves and the energy associated with those. As we're producing more energy, we're just going to need more of the higher electricity power lines, but those have the ability, because they're not coated in anything to kind of protect them. If anything touches those, they kind of just catch on fire. So that's actually led to wildfires in California, those high power lines. A tree branch or something like that falls onto it, it just catches on fire, and then that's able to kind of get the entire fire going. But with these, we've talked about quite a few different energy options, from the fossil fuels that get used quite a bit to the greener alternatives that hopefully we continue to move more and more towards, so that we can reduce these greenhouse gas emissions. And ultimately, we would want to get to a point where the carbon emissions, those greenhouse gases, where we're not emitting any of them, just so that we're not further contributing to global warming. And ultimately, if we want to do that, we're going to have to make certain changes like we can see here. So we're going to want to increase our usage of those of those greener alternatives. So we're going to want to increase solar and wind capacity. So just more solar panels, more wind turbines. Again, we're going to want to think about how we do that so we can do it effectively, can do it smartly. because we're not just going to want to set up wind turbines and solar panels kind of willy-nilly and wherever we feel like. We're going to want to actually put some thought into that. And we're going to want to use those to hopefully be able to reduce the amount of energy that's being produced from coal. So if we can switch from solar energy or from coal to solar or wind energy, we'll be able to reduce those greenhouse gas emissions. And this isn't going to be just a one-step process, but if we can continuously make steps in that correct direction, then ultimately we could hopefully get to a point where we do actually see net zero carbon emissions. And then other things that we haven't exactly talked about in terms of energy, switching transportation to zero emission vehicles would obviously be a huge benefit. So electric vehicles or switching to just hybrid vehicles in general, something that's going to improve the efficiency could go a long way, because that's also going to reduce the amount of energy we need if we can improve the efficiency of those vehicles. They want to improve the homes themselves. So if we can use geothermal to help heat those homes and buildings, if we can seal those buildings in a more efficient way so we can maintain the heat so we don't have to heat it as much. Obviously, that's going to reduce the amount of energy, reduce the amount of emissions that we're producing. And then some of the other ones we've talked about. So again, 6 kind of goes into that last point I made, just making buildings and things like that more efficient. But we've also got innovation to hopefully capture those emissions as well as they are produced. And with this, just to kind of talk about it, because we didn't explicitly put it in here, with the energy usage, we looked at the different sources of those usage, or the sources of those that energy, where that energy is being produced. Excuse me. But what you also would want to think about is the amount of energy you're using. We talked about it with the different resources when we're looking at water and things like that. But we can always conserve energy. And in that case, we wouldn't need as much energy produced. So that would help reduce the emissions as well. So with this chapter, hopefully you're getting an understanding that as we move from fossil fuels to greener alternatives, it's not just going to be one alternative that's going to solve all of our problems. We're going to need to use a collection, a combination of those alternatives. So solar, wind, hydro, nuclear, geothermal, whatever it may be. But we're also going to want to think about how we live our lives in terms of the amount of energy that we use, and try to identify ways that we can kind of decrease that ourselves as well.